Okay, so so this is the discrete Fourier series representation. Okay, so any periodic sequence xn can be represented as a collection of exponential terms. Okay, jk omega naught n. So this omega naught is the fundamental frequency. Omega naught is given as 2 pi by n naught. N naught is the fundamental period. Okay, n naught is the fundamental period, and you have to find this collection from 0 to n naught minus 1. Okay, so if you find more value, those are the same value. Okay, we have checked this. Okay, so it is enough to find 0 to n naught minus 1. Okay, and the ck, this ck is this weightage. Okay, this is we called as Fourier coefficients. So that is given as 1 over n naught xn into e minus jk omega naught n. That is also from 0 to n minus 1. Okay, so you have to, so this identity will be given. Okay, these identities will be given and you have to know how to apply them. Hari, menna මේවා දෙනවා. ඔකට දැනගන්න ඕන මේවා apply. Hari, so we will consider one example. අපි දැන් example එකක් කරමු. Hari. Okay. Now, so you have to, so I told you that these are for periodic signal. Okay, so these are for periodic signal. So the periodic signal one will be, sorry, these numbers will be changed. Okay, these numbers are wrong actually. Okay, so actually you are asked to do the work for these signals. Okay, these signals. Okay, you are asked to do the work for these signals. Okay, so here actually we get only this one. Oh no, this one also not a periodic signal. No. Okay, so here actually we doesn't have any periodic signal, unfortunately. Okay, so let's say that this one. Okay, let's say this one. Okay, so I will take this signal as example. Okay, no. Okay, give me a moment. Okay. Sorry, I'm sorry. Okay. Actually, I am asking about the solve problem. Okay. The solve problem means here, not these signals. Okay. Solve problem in our reference book. Okay. Show outlines. Here it is status. No. Okay. So if you consider the show outlines. Okay. So that is solve problem, okay? And discrete Fourier series, we are asked to do, you are asked to do 6.4, 6.5 and 6.6, okay? So 6.4, so 6.4, let's try to find 6.4, this one, okay? So also this is the signal, okay? This is the given signal, okay? This is the given signal, and first you have to find the Fourier transform, then you have to determine the magnitude spectrum, okay? Magnitude spectrum, only the magnitude spectrum, okay? Not the phase spectrum, okay? So we will try to do this question, okay? So it is given in your reference book, okay? Actually I'm confused. Sorry, මට පොඩ්ඩක් පැටලුණා. හරි. මොකක්ද මම මේක පාට මෙතන උඩ දාලා තියෙන සිග්නල් වල හොයන්න තියෙනවා කියලා. හරි. එතකොට ඔකට හොයන්න ඕන මේ සිග්නල් වල. You need to find these signals. The Fourier series representation of these signals, okay? So we will take this one first, okay? This one first. Give me a moment, okay? So I get this signal. Okay, I'm sorry for the late, okay? So anyway, this is your question, okay? So this is your question. I hope you can see it, okay? So now you are asked to find, the Fourier series representation of the signal, okay? And you need to sketch the magnitude spectrum, okay? So we will try to do this, okay? So first, okay? So this should be periodic signal. This should be periodic signal, okay? So you can note that this is the periodic signal. If you consider any sample, let's say that this sample, okay? So it is repeating here. This one is repeating here again, okay? So if you consider this sample, again it is repeating here. So this one is repeating here again, okay? So the samples are repeating, okay? So this is a periodic signal and you have to find this period. To find the period, you have to find the next repeating point, okay? So the periodic is, you can count the sample 1, 2, 3, 4, okay? So this zero is repeating after fourth sample. If you consider this one, this is repeating after fourth sample 1, 2, 3, 4. Okay. So this one is repeating after fourth sample. Okay. So every sample is repeating after fourth sample. So the period is 4. The n naught is 4. Okay. So you have found the period. Okay. Then you can represent this xn as a collection of complex exponential term gk omega naught n. Okay. So this will be ck. The k will be 0 from n naught minus 1. That will be that is 3. K from 0 to 3. Okay. So this is the representation. This is the representation. And you have to find the ck value, the Fourier coefficients. Okay. To find the Fourier coefficients, you are given the identity 1 over n naught sigma n from 0 to n naught minus 1 xn e to the power minus jk omega naught n. Okay, so this omega naught is actually the fundamental frequency that is equal to 2 pi by n naught. Okay, so you know the n naught, so you can find the omega naught also. Okay, so let's see how to do this one. Okay, so this is the general form. Okay, for our question, the ck, the n naught will be 4, and you have to evaluate the value from 0 to 3, n naught minus 1, 4 minus 1, 0 to 3, xn e to the power minus jk omega naught n. Okay, so first we try to find the Fourier coefficients. Okay, actually you are asked to determine the Fourier coefficients ck. Okay, so you are asked to find the Fourier coefficients ck. Okay, so you can easily find the ck. What you have to do is that you have to apply the value. Okay, so if you consider the zeroth value, okay, so this you have to find from 0 to 3. Okay, 0 to 3, this k from 0 to 3. Okay, so you have to find this ck value. The k will be from 0 to 3, that means will be 0 0 1 2 3. 0 ඉඳන් 3ට එනකල් තමයි ඔය කට්ටිය හොයන්න ඕනේ. මේ ck value හරි බිඳුවේ ඉඳන් 3ට එනකල්. බිඳුවේ ඉඳන් n naught minus 1. n naught කියන්නේ period එක, fundamental period එක 4යි, 4 ඍණ 1 3යි. එතකොට බිඳුවේ ඉඳන් 3ට එනකල් තමයි ඔය කට්ටිය හොයන්න ඕනේ. හරි? ck හොයන්න ඕනේ බිඳුවේ ඉඳන් 3ට එනකල්. එතකොට අපිට හොයන්න ඕන ඇත්තටම c බිඳුව හොයන්න ඕන. We need to find c0, c1, c2, c3. Okay, so you have to find 4 Fourier coefficients. හරි, ඔකටට හොයන්න ඕන Fourier coefficients 4යි. හරි, right. So let's start from beginning. Let's try to evaluate the c0. c0 means k is equal to 0. Okay, k බිඳුවේදී c coefficients එක හොයන්න ඕනේ. ඒ කියන්නේ අපි ඒක කියනවා c naught කියලා. c බිඳුව. Okay, so to find the c naught you have to use this identity, this one. Okay, so the c naught will be 1 over 4 sigma 0 to 3, that is n. Okay, n is from 0 to 3 xn e to the power minus jk omega naught n. Now the k is 0. K is 0. So this will be e to the power 0. හරි, k කියන එක බිඳුවයිනේ. එතකොට මෙයා ඉන්නේ e to the power බිඳුව. e to the power බිඳුව කියන්නේ 1යි. So this will be c0. Okay, so the value is 1. Okay, so c naught is equal to 1 over 4 n from 0 to 3 xn. Okay, so you have to evaluate this one. So you have to expand this. Okay, මෙතන තියෙන්නේ summation එකක්. xn හොයන්න තියෙනවා බිඳුවේ ඉඳන් 3ට යනකම්. බිඳුවේ ඉඳන් 3ට, ඒ කියන්නේ you have to find xn from here to here. Okay, so if you find other value, so this one, okay, this one is repeating here, so you have the same value here. So that is why you need to do up to this point, n naught minus 1, that is 3. Okay, so up to this point. Okay, 0 to 3. Okay, තේරුණානේ නේ? දැන් 4 වෙනි එක හෙව්වොත් එහෙම ඔකට්ටේන මේ බිඳුවට එන වැලියු එකමයි ආපහු වෙන්නේ. එතකොට ඒක රිපීට් වෙනවා. එතකොට ගාන වැරදෙනවා. හරි. ඒකින්ද තමයි බිඳුවේ ඉඳන් n naught minus 1ට එනකල් හොයන්න කියන්නේ. එතකොට n naught minus 1 කියන්නේ හරියටම මේ එක සිග්නල් එකක් ඇතුලේ, එක කෑල්ලක් ඇතුලේ තියෙන සාම්පල් ගාන තමයි ඔකට එකතු කරන්නේ. හරි. So you have to add the sample in one section. හරි. මේ section එකම තමයි ආපහු repeat වෙන්නේ මෙතන. තේරෙනවද? මේ section එකම තමයි මෙතනදී ආපහු repeat වෙන්නේ. ඒ section එකම ආපහු repeat වෙනවා. හරි. This section is repeating here. This section again repeating here. This one. Okay. So that one again repeating here. Okay. Like this is again here. Okay, so you have to find the value within this one, only one section. මේ එක section එකක් ඇතුලේ තමයි හොයන්න ඕන value එක. හරි, බිඳුවේ නම් 3ට යන්න. හරි. So now 0 to 3 you have to find. Okay, so c naught is equal to 1 over 4 x0 plus x1. This is a summation. Okay, so you have to add them, x1 x2 plus x3. Okay, so what is the value of x 0. So this will be 1, 2, 3. Okay. X0 will be 0. X1 will be 1. X2 will be 2. X3 will be 3. Okay. So you have the C naught value 1 over 5, 0, 1, 2, 3. So you will have 1, 2, 3, 3, 6, 6 by 4. That is 3 by 2. So that is 1 point C naught. Okay. In the same way, you can find C1. Okay. The C1 is K is equal to 1. Okay. So here the K is equal to 1. So you can use the same identity 1 over 4 sigma n from 0 to 3 xn e to the power minus j. K is now 1. Okay. Omega naught is there and n is there. Okay. So you have to find this value. Okay. So now you can apply the value and you can expand this, the n value. Okay. So you have 1 over 4 here. Okay. So now n from 0 to 3. Right? Okay. හරිනේ මේක තමයි ඔකට දැන් expand කරන්න ඕන මෙන්න මේ කැලේ. හරි එක යට හතර තියෙනවා. එතන මෙතන එනවා x බිඳුව e to the power n කියන්නේ බිඳුවයි. එතකොට e to the power 0 plus x1. දැන් මේ e to the power දැන් මෙතනදී ඔක්කොගෙම k කියන එක 0 වුණානේ. k is 0. This value is 0. එතකොට මෙයාගේ e to the power value නෑ මොකද. හරි මෙයා හොයන්න. But when it's come to here, there are some e to the power value. හරි e to the power value තියෙනවා. එතකොට ඒ e to the power value එකත් ඔකට consider කරන්න ඕන. You have to consider that value also. Okay. So this will be e to the power minus j. Now k is 1. Omega naught n. Omega naught actually omega naught is equal to 2 by 4. Okay. 2 by n naught. So that is 5 by 2. Okay. Omega naught is equal to 5 by 2. Okay. Omega naught is equal to 5 by 2. So I am writing omega naught here. Later we can substitute this value 5 by 2. So this will be e to the power minus j1 omega naught plus x2 e to the power minus j1 k is 1 omega naught. Now n is 2. Now you have 2 plus x3 e to the power minus j1 omega naught 3. Okay. So you have these values. Okay. Okay. So you have 1 over 4. The x naught value will be 0 plus x1 value will be 1 e to the power minus j. Omega is 5 by 4. Now I will add, okay, 5 by 2. Okay, plus x2 is 2 e to the power minus j. Okay, I'm sorry. Okay. මම අප පටන් ගන්නම්. දැන් n2 හරි n2 නේ අපි ගන්න. So n is equal to 2. So x2 value will be to x1, x2 ne metana. X2 value will be 2. X deke value එක එකනේ. x දෙක මේකනේ x දෙක. එයාගේ value එක 2යි හරි. මේක x බිඳුව. මේක x1. මේක x2. මෙයා x3. හරි x3 දානකල් විතරක් වන්නේ. ඒතර x1 value එක බිඳුවයි x2 value x1 value එක 1යි. x2 value එක බිඳුවයි x3 value එක 3යි. හරි. ඒක මතක තියාගන්න. හරි. So x2 is 2 e to the power minus j, k is 1. Okay, we are finding k is equal to 1. No, here k is equal to 1. K is equal to 1. Omega naught is 5 by 4, 5 by 2, and this is 2. N is equal to 2, so you have 2 here. Okay, and 2 cancelled, so you will have this value plus x3 value, that will be 3 e to the power minus j k. K is 1. Omega naught is 5 by 2, 3. Okay, so this is the value. Okay, so you have 1 by 4, 0 e to the power minus j 5 by 2 plus 2 e to the power minus j 5 plus 3 e to the power minus 295 by 2, 35 by 2. Okay, so this is the C1 value. Okay, so using a calculator, you can simplify this. Okay, you need to have the scientific calculator because you will have some, these are j values. No, these are j values, so this will be this also will be same. So sum of this value will be will be complex value. Okay, but easily you can find this value using the complex plane. හරි, complex plane එක පාවිච්චි කරලා මේ වගේ value හොයන්න පුළුවන්. හරි, මේ e to the power minus j theta වගේ එකක් આવුත් e to the power minus j theta මේක complex value එකක්. හරි, මේවා අපිට ලියා ගන්න පුළුවන් Euler formula එකෙන් cos theta minus j sin theta කියලා. මේක තමයි Euler formula එක. හරි, මෙතන plus આવුත් මෙයා plus වෙනවා. හරි, so you can write any complex number like this. Okay, this is we call the polar form. මේකට අපි කියනවා polar form එක කියලා. එතකොට මේ මෙතන තියෙන magnitude එක, the magnitude is 1. හරි, මේ තියෙන phase එක, phase එක is theta here. Okay, so if you represent e to the power minus j theta complex value, complex number in x-plane. Okay, this is the real axis, this is the imaginary axis. Sorry, මේකනේ explain එක කියන්නේ real axis එකයි imaginary axis එකයි. මේක තමයි අපි explain එක කියන්නේ. හරි, ඒක මතක තියාගන්න. මේවා high studies වලට හැම යනවා නම් ඔය කට්ටියට මේවා ඕන වෙනවා ඉස්සරහට. හරි, එතකොට real මේක imaginaries. හරි, එතකොට e to the power j theta minus j theta මේක මේ වගේ signal එකක් නෙන්නේ. හරි, එතකොට මෙයාගේ මෙතන magnitude එක ඒක එකයි. magnitude එක කියන්නේ මේ r වල මෙන්න මේ value එක. එතකොට ඒක එකයි. මෙයාගේ මෙන්න මේ කැලේ දිග. හරි, දැන් මේක θ. θ කියන්නේ මොකක් හරි කෝණයක්. හරි, එතකොට මේ ඔය කට්ටියට මේ e to the power minus j θ කියන එක value එක මෙන්න මේ වගේ තැනක පෙන්වන්න හැකියි. දැන් මේ θ කියන එක minus නේ. minus කියන්නේ යාව කරකින්නේ මේ පැත්තට. හරි, මේ පැත්තට තමයි කරකින්නේ. එතකොට minus θ නම් මේ පැත්තට එන්නේ. So e to the power minus j theta, that the phase is 0, minus value. So you have to measure the phase in this direction. හරි, එතකොට මේක minus theta මේ පැත්තට එන්නේ. හරි, දැන් මෙතන ඔය කට්ටියට හොයන්න තියෙන minus 5 by 2. දැන් මේ ගත්තොත් එහෙම theta කියන එක 5 by 2 වෙලා minus. ඒ කියන්නේ මේ පැත්තට කරගිලා මෙන්න මෙතෙන්ට එන්න ඕන. මේ value එක 1 නේ. හරි, එතකොට මෙයාගේ value එක තියෙන්නේ මෙන්න මෙතන 1. හරි, මේ θ කියන එක මෙතෙන්ට කරගිලා එනවා 5 by 2 වල. හරි, එතකොට මෙතන එන්නේ minus j. හරි, එතකොට මෙයාගේ value එක ඇත්තටම minus j. මෙයාගේ value එක මොකද්ද? එයාගේ -j5 -5 කරකිනවා. ඒ කියන්නේ මෙයා මෙතෙන්ට එනකල්ම කරකින්න ඕනේ. දැන් මේ වැලියු එක 1. එයා එක අරයක් තියෙනවා. එයාගේ මැග්නිටියුඩ් එක එකයි. හරි. එතකොට මේක කියන්නේ රියල් ඇක්සිස් එක. රියල් ඇක්සිස් එකේ -1. හරි. එහෙනම් මෙයාගේ වැලියු එක ඉන්නේ -1. ඒක දෙකෙන් වැඩි කරපුවාම -2. හරි. මෙතන මොකද්ද? 3 5/2. 3 5/2 කියන්නේ තව 5 එකක්. මේක එක 5/2, මේක දෙකයි 5/2, මෙතන 3යි 5/2. 3යි 5/2 කියන්නේ මේ පැත්ත +j. ඉමේජිනරි ඇක්සිස් එකේ 1. ඒ කියන්නේ +j. එතකොට මෙයාගේ වැලියු එක එන්නේ +j. මේක 3. හරි. එතකොට C1 වල වැලියු එක ඇත්තටම කට්ටියට එන්නේ 1/4. This is -j plus this is -1. That means -2 plus 3 plus j. So you will have 3j here. Okay. So ck is C1 is equal to 1/4 minus j plus 3j, that is 2j minus 2. 2j minus 2. Okay. So this is the C1 value. Okay. So if you find it up to this level, you will get the full marks, no problem. Okay. So anyway, you can simplify it up to this level also. Okay. Using this one. Okay. So you can get a proper answer. Okay. You can get a proper answer. හරි. අනිත් එක තමයි magnitude spectrum එක අඳින්න යනකොට මෙතෙන්ටම සුළු කරගෙන ඉන්න එක ලේසි අත්තටම. හරි. When you are going to draw the magnitude spectrum, it is better to come up to this level. Okay. Otherwise it will be somewhat hard to do. Okay. But using the Euler formula also you can find. Okay. You can use any method. Hurry. Or method that use කරන්න පුළුවන්. Right? Okay. Now you have to find the C2 value. That is k is equal to 0. K is equal to 2. That is C2. Okay. So to find C2, k is equal to 2. Okay. That is C2. So C2 will be 1/4 sigma n from 0 to n0 minus 1. That is 3. Okay. Xn e to the power minus j. K is now 2 omega naught n. Okay. So you have to expand this one. Okay. So C2 is equal to 1/4 sigma. That is the addition from 0 to 3. So n from 0 to this is n from 0 to 3. So x0 e to the power minus j omega naught n is 0. So it will be e to the power 0 plus x1 e to the power minus j. K is equal to 1 omega naught n also equal to 1. Okay. Plus x2 e to the power minus j. Sorry, k is equal to 2 now. Okay. The k is equal to 2 now. Omega naught 1. Here the k is equal to 2. Omega naught n is equal to 2. Okay. Plus now n is 3. X3 e to the power minus j. K is equal to 2. Omega naught n is equal to 3. Okay. So you have to find these values. Okay. The same procedure you can follow. Okay. So C2 is equal to 1/4. X0 is 0. So that is vanished. There is no part here. 0 value. Okay. X1 is 1 e to the power minus j. Omega naught is 5/2. Okay. 5/2 into 2. That is 5. Okay. Minus j5 plus x2. That is 2 e to the power minus j. Now 5/2. 2 to cancel. Then 2 5. It will be 2 5. Plus 3 e to the power 5/2. So it will be 3 5. 5/2. 5/2. Here the 5 naught is 5/2. And it is multiplied by 2. 5/2 into 2 into 3. So 2 cancelled, so it will be 3, 5. Okay. So you have to find these values. Okay. To find these values, you can use the same circle. Okay. So now it is minus. So 5 is minus 5. That means you are rotating this direction. This is 5 here. So that will be minus 1. So this value will be minus 1. And again 2, 5. 2, 5 means 1, 5, another 5. This will be 2, 5 here. Okay. 360ක් කරගෙන. මෙතෙන්ට එනවා. එතකොට ඒක +1. මෙතන value එක +1. 3, 5. 3, 5 means this is 1, 5, 2, 5, 3, 5. Again here. So this will be -1. Okay. So C2 is equal to 1/4. This is -1 plus 2 minus 3. Okay. So you will have 1/4 -1 minus 3 minus 4 plus 2. It will be -2. So it will be -1/2. Okay. So that is C2 value. In the same manner, you can find the C3 value also. C3 value also. Okay. So I think please try to do it by yourself. Okay. So these are K values. Okay. Actually, they use another method. Okay. But you no need to go through that method. Okay. Let's check our value is correct or not. මේකට මේ අර පොදු විදිහකට හදලා ඒ විදිහට ගිහිල්ලා තියෙනවා. දැන් ඒ විදිහට කරන්න යන්න අවශ්‍ය නැහැ ඔය කට්ටිය. මට සාමාන්‍ය බේසික් මේකෙම ගිහ හැකි. හරි. sorry මේක 6 3 හරි. මෙන්න මෙයාව මේ 6 7 6 8ට යූස් කරන්න කියලා තියෙන්නේ මේ මෙන්න මේක. මෙන්න මේක හරි මම පොඩ්ඩක් පටලවා ගන්න. මෙතන ප්‍රශ්නයක් කරගන්න එපා හරි. දැන් මම ඇත්තටම හැදුවේ මේ 6 3 තමයි හදලා තියෙන්නේ මම. හරි. I have done the පොඩ්ඩක් බලමු. -j35. ඔව්. -j35 තමයි. මට තේරුන්නේ නැහැ අහන ප්‍රශ්නේ. 35 35 නේ අපි හෙව්වේ නේද? -j35 නේ හෙව්වේ. මෙතන කියන්නේ නේ. sorry. This is minus j. Okay. Sorry. This is minus j. Thank you. Okay. This is -j35, but the value is not same. Okay. -j means here it is rotating in this direction. 1, 2, 3. 3, 5 is -1. Okay. So the value will be. So actually we have done this question. Okay. මෙන්න මේ 6 3 තමයි හැදුවේ. හරි. 6 3 තමයි අපි හදලා තියෙන්නේ. හරි. එතකොට C note එක 3 බෙදීම දෙකක් ආවා. C1 එක මේක දාවේ අපිට. C1 වලට අපිට ආවේ. හරි. මේක බෙදුවොත් එහෙම මෙතන එන්නේ j/2 minus 1/2. j/2 1/2. Okay. C1. හරිනේ ඒකනේ. හරි. ඊළඟට C2 ආවේ -1/2. හරි. -1/2. So C2 -1/2. -1/2. In the same manner, try to find the C3 also. Okay. So C3 value will be this one. This one. Okay. Same manner, try to find this one also. Okay. And then you have to draw the spectrum. Okay. You have to draw the magnitude spectrum. Magnitude spectrum means, okay. So I told you that. So CK, you can so this value will be a complex value. Okay. This Fourier coefficients will be a complex value. Okay. So you have the magnitude then e to the power minus j theta. So this will be the magnitude and this theta will be the phase of this complex number, okay? So with respect to k, if you plot this ck, magnitude of ck, it will be the magnitude plot. And if you plot the phase, it will be the phase plot, okay? So here you can easily draw the magnitude plot, okay? ලේසියෙන්ම ලියන්න පුළුවන් magnitude plot එක. හරි. The C naught will be 3/2. හරි. C naught එක 3/2. C1 එක complex value එකක් එනවා. ඒක ආවේ minus half j plus half the අනිත් පැත්ත. Plus half j plus minus, okay? And C2 we will have minus 1/2, okay? And C3 also there is a value, we haven't find it yet, okay? So you can find it, okay? So what is the magnitude of C naught? The magnitude is 2/2 itself, okay? So what is the magnitude of this one? Square of this one and plus square of this one. So 1/2 square plus 1/2 square. So it will be 1/4 plus 1/4. That means 2/4. Square root of 2/4. So it will be the square root of half. Correct? This is square plus, this is square, 1/4 plus 1/4. That is 2/4. That is square root, square root of 2/4. Then it will be 1/2 square root. Okay, so this is the magnitude. And what is the magnitude here? It will be plus 1/2. Okay, so this is the magnitude and this is the magnitude, this is the magnitude. So you can easily draw that. Okay, so if you plot the magnitude plot, okay, the k from 0 to 3, 0, 1, 2, 3, okay, the magnitude of C0 is 3/2, okay, that is 1.5. The magnitude will be 3/2, okay, and the first one, C1, magnitude is root 1/2, okay, so it will be here, somewhere here, okay, and C2, the magnitude is 1/4, okay, so it is somewhere here, okay, okay. And also you have to find the magnitude of 3 also, okay. So you have plot the magnitude versus k, okay. This is the magnitude, this is the magnitude, ck, magnitude of ck with respect to k. So this will be the magnitude plot, okay. And if you plot the phase, okay, phase is if you plot the phase, okay, this is the phase. So normally we can write it like this, okay. This is the phase of ck with respect to k, okay. So what is the phase? The C naught value is 3/2, okay, and C1 value is 1 plus J2, C2 is 1/2 minus, okay. So these are the value we have found, okay, and C3 value is there, find that one also, okay. So what is the phase here? This is a real value, okay, the phase is 0. And what is the phase here? So it will be minus, so if you plot it in the complex plane, the C1, it is minus 1, 2, and here, and plus J2, like this, okay. So you have to find this value. You have to find this value. Actually, you can get the tan value, okay. Tan inverse, this is imaginary axis, that is 1/4 divided by 1/2, okay. So it will be -1. So if you get the tan inverse -1, you can get the value here, phase value, okay. So C0 phase is 0, okay. C1 you will get the value here, -1. What is the tan inverse -1? It is 5/4 minus 5/4. I'm not sure. -5/4 means it is not -5/4. it will be 90 5 by 2 by, I don't know, the value may be some value there, okay, and again C2, the phase will be 0 again, okay. So in the same manner, you can draw the phase plot also, okay. So try to plot it, okay. uh, we have done some question here, and also in the reference book also there are some example, okay. So try to do that one, okay. And so again, in 6.4 you are asked to find the Fourier representation of this 6.8, that is in this here. You have to find the you have to find the Fourier series representation of this signal, okay. May signal එක හොයන්න තියෙන්නේ, right. What is the period of this signal? I think we have done this question, okay. අපි මේ question එක හැදුවා මේ මොකක්ද class එකකදී. මට මතකයි. හරි. එතකොට දැන් මේකත් හරි ලේසි. මෙයාගේ n naught කියන්නේ මෙයාත් periodic signal එකක්. This is also a periodic signal, okay. This is also a periodic signal, okay. So it is so you can see that this one is repeating here, okay. So this is one section. මේක තමයි එක section එක. This is one section. This section is repeating here again here, okay. So this is another section, okay. So you can see that this sample is repeating here, okay. So you have to count the sample from here to here. So that is 1 2 3 4 5 6 7 8 9 10, okay. So your naught will be 10, okay. So that is your period, okay. So you can find omega naught, that is 2 5 by n naught, okay. So that is 5 by 5. You can find the n naught, okay. So you have to find your integration from k from 0 to, not the integration, summation from 0 to n naught minus 1, that is 0 to 1, okay. So here you have to find 10 Fourier coefficients, k from 0 to 9, 1 2 3 4 5 6 7 8 9. එතකොට බිඳුව ඉඳන් 9ට යනකම් Fourier coefficients හොයන්න ඕන. C බිඳුව, C1, C2, C3, C4 වගේ. හරි. එතකොට අර 9ට යනකම් හොයන්න ඕන. හරි. So same identity you have to use. අර එකම identity එක තමයි use කරන්න තියෙන්නේ. ඒ කියන්නේ එකම ක්‍රමයට මේ ඔක්කොම හදන්න තියෙන්නේ. ඒ ක්‍රමයට පොඩ්ඩක් familiar වෙන්න තියෙන්නේ, okay? You have to familiar with that question, with that method, okay? So same manner you can find this C0, C1, C3 up to C9, okay. So this some value will be maybe real value, some value may be complex value, okay. So anyway, complex or real, you can find the magnitude. To find the magnitude, if you have a complex number like this, a plus ib, the magnitude of this one will be a square b square square root, okay. So using this equation, using this identity, you can find the magnitude and you can find the phase. Then if you need, you can find the phase plot or magnitude plot, okay. So the same procedure is there. There is no any special, okay. දැන් අමුතු දෙයක් නෑ. ඔය කට්ටියට අර familiar වෙන්න තියෙන්නේ මේ procedure එකට. ඒ කියන්නේ මොකුත් හිතන්න දෙයක් නෑ මේකේ. procedure එක පොඩ්ඩක් මතක තියාගන්න තියෙන්නේ. හරි. Then you can find that one, okay. Okay.